Peter Hill Explains, where I invite you to join the science teaching conversation with me about using CRISPR gene editing technology to edit a sperm. This is a July 7th, 2018 New Scientist article by Frank Swain and Michael Laplage, entitled "Can we edit sperm DNA before it meets the egg?" For the first time, biologists are trying to get CRISPR gene editing machinery directly into mature sperm rather than into fertilized embryos. The work is still at an early stage, but could lead to a new way to prevent inherited diseases. Around half a dozen teams have used CRISPR-Cas9 genome editing method to alter the DNA in the nucleus of human embryos, but it is still far from clear whether this approach is safe for correcting faulty genes. One issue is that the cell division may start before the DNA is fixed, meaning the gene is altered in some but not all cells in the developing embryo. This phenomenon is called mosaicism. So Danielle Quay and her colleagues at Weill Cornell Medicine in New York are experimenting in delivering DNA coding for CRISPR machinery to mature sperm cells rather than to embryos. On Tuesday, the researchers announced that they may have found a way to do this that allows the sperm to remain relatively healthy and potentially capable of fertilizing eggs. In theory, a single gene disorder transmittable by the male can be treated if we are able to successfully use CRISPR-Cas9 on sperm, says Quay, whose team presents its approach at the European Society for Human Reproduction and Embryology conference in Barcelona, Spain. It might be possible to use such gene editing to prevent fathers from passing a wide range of genetic disorders. For example, it could enable two people who both have the order such as cystic fibrosis or sickle cell anemia to have a child together that would be free of their condition. Their work is still at an early stage, however, and Choi's team has yet to show whether the gene editing machinery works inside the sperm. If we could do the editing in a sperm, this would be fantastic, but it's a big if, said Tony Perry, the University of Bath in UK, a leading CRISPR researcher who was not involved in the latest work. I think it's unlikely, but I would love to be proved wrong. One way to get DNA inside cells is to zap them with electricity. The challenge with sperm, which wrapped in tough fibrous cuticle, is doing it without disabling them. The team says a single 1,100 volt pulse of electricity, just 1/50th of a second long, does the trick, though it does reduce sperm mobility by half. So the team first selected the strongest and healthiest sperm before zapping them. This meant this resulting sperm was still good enough for swimmers to be used in IVF rather than needing to be injected into the egg. The big question is that what happens next? Getting the DNA for CRISPR machinery into a cell is only the first of several steps needed to successfully find and change the DNA of a gene. It's not yet clear if any of the subsequent steps can happen in the sperm. For instance, sperm DNA is tightly packed, so CRISPR complex might be unable to search through it and find the target gene until after the sperm is fertilized an egg. This means a risk of mosaicism would remain, although this wouldn't matter when treating some conditions. Well, that's hard to understand. Oh, okay, yes, I do understand. So so the DNA in sperm is really tightly packed. That's an interesting thing. The interesting thing is that DNA is elastic. It springs apart, and so you can actually compress it down like too many socks in a drawer. They spring out. There is a lot to understand and discover about the sperm nucleus, which makes our project more difficult. Perry says that several teams around the world have tried hard to genetically modify mature sperm using older techniques without success. But no one else has tried with CRISPR, as far as he knows. Another podcast, another story comes to a close. It's been a pleasure sharing this moment in time with you. May you discover truly amazing things understand them and tell others. Thanks for listening.